So the whole idea behind building a bliff was to carry a hook up to the roof exactly above Bruce's office and drop it so that it hooks onto the railings. So our idea was to have a digital compass which would give us the heading. So the natural lift of the balloon would take it up to the roof and the compass would tell us where to go. But it turned out that we couldn't get the compass running. So all we did was let the balloon rise and let the wind take it to the roof wherever possible. And then there was this small sonar sensor at the front which detects the edge of the roof. So as soon as it detects the roof, it would take multiple readings to make sure it's on the roof and then release the hook. So at the third go, it actually went up and dropped the hook, but again at not the right location, somewhere off target. So we were able to detect the roof and drop the hook, but not at the right location.
Really, really slowly.
Yeah, that's one thing we sort of sped up in the movie. We wanted to make sure we could open the window as a pretty important concern. And at the same time, we didn't know how much force it would take. So this guy's capable of lifting 150 pounds.
And while we're going up to make sure we kept the window opener against the side of the window, we had some flaps and they'd go out, push against the window, flip us over so our front face was against the glass. Then once we got positioned, open the window. The next part was to climb inside. We had 2 grappling hooks on air cannons. So basically, you could shoot out the front, hook on, in our case, hook on a chair and a desk. I have CO2 cartridges for those. I had a lot of problems with leaks on them. They kept, during the final filming, both cannons leaked. Then we could retract those back in and
pull ourselves forward into the room. Other than that, it really was pretty reliable. I mean, we can, if we want to like this, we could get in the room pretty reliably right now, with the exception of maybe firing the air cannons. Everything else, I would be pretty confident in seeing it work right now.
So everybody's seen in like Hollywood movies where the guy puts on a stethoscope and puts up the safe and starts spinning the dial to figure it out. That's not just Hollywood, that's a real way that people do it. So we tried to emulate that technique, and that's what the contact mic accelerometer does. And, you put it on a solid surface and you tap on the surface and you pick up those vibrations, which you can also hear.
The way it works is there's a cam that the lever falls into each one. It's hard to see. It's there's a really complicated algorithm. What it does is, because there's 3 wheels, one of the wheels has to be slightly bigger than the other ones. So when you rotate it, if that bigger wheel has the gate open so the lever will fall slightly more, then the click that you hear when you're rotating will be slightly closer together. And we have to be able to detect where those clicks happen. We can't hook this up to the safe and open as of now. We actually want to keep trying over the summer. But we can sense the contact points when those clicks happen. If we moved further, we would have to write the algorithm and compare each step. We also finished the position control on it so that we can, given our combination, we can put it in and open the lock.
This started out originally as a autonomous aiming turret that shoots anything that moves in the field of sight of the camera.
Laser?
And has laser ranging. But now it's just a turret that you can manually control from the keyboard and shoot it.
Or from MATLAB.
Or from MATLAB.
Finding the theta direction as to where to go side to side, we have just a standard webcam which takes a master frame, and then whenever the image changes, it finds the center of the difference. And so when the tolerance between the laser and the centroid of the disturbance is within a certain tolerance, it will begin firing. That was the plan.
You talk about the electronics at all?
Oh, the electronics.
So basically all these motors are connected through H bridges to a microcontroller that's talking through serial to the computer, and you can either just get like a nice Doom style interface with WASD to move it around and fire, or you can hook it up to MATLAB and send serial commands to get it to do anything, to do things, which is what we were working on. What we were using to do the vision stuff.
So our idea was to use modules, including radio frequency technology and GPS chips, to do the same thing and integrate that with a GUI so you could track someone up to 6 miles away, see their position, where they're going. Or if you wanted to split up the modules, originally the plan was that you would put 3 on one car, So you would have extremely accurate bearing information and location information suitable for Maverick missile strike. You could split up the modules and put them on people. So you could have up to 3 moving targets and coordinate your tracking and capture all from the same graphical user interface.
So this is what we wound up with. We only actually made one, but it does work. And you can see the GPS talking. It's not going to give us any location because we're inside and it doesn't have an antenna on it. This GPS module is wirelessly transmitting its location to the computer over Zigbee, and it was coming in through that little GUI. The GUI saves to an XML file where this custom-made website by Xander takes in the XML file and plots it on Google Maps.
Originally it was supposed to go under Bruce's door, but we found out that Bruce's door has like a 0.5 millimeter clearance. So we decided to go under Jonathan's door, which is about 16 millimeters, which is doable, this is about 13 or so. And we have treads, so it's like a tank tread.
So we have a wireless 2.4 gigahertz wireless camera, and on the front we also have an IR sensor. We can turn it on and off from here. So it's pretty much remote control.
Everything that was in that video, we actually did do, so it wasn't fake.
And that's pretty much the circuit. It's actually very simple, but trying to get it to this size is actually pretty tough.